So the final consideration for electrolysis and electrolysis of aqueous solutions in particular is what happens with chlorine or chloride solutions. So the chloride ion is Cl minus. And some strange things, unexpected things happen when we have chloride solutions, and it's actually concentration dependent. So we know that at the Po electrode, the positive electrode, we know Po is a pain. And so that's where we have to really look out for strange things happening. We've already seen this with sulfate and nitrate. If the anion in the solution is sulfate or nitrate, then we know that we get to ignore them as an oxidation possibility. And so then we just look at water's oxidation, which produces oxygen gas. We've then seen that if the positive electrode is built out of a metal, such as copper, rather than being an inert electrode like platinum or graphite, that we also have to consider that metal oxidizing and dissolving off into the metal ion is the oxidation half equation or the oxidation process. The final thing is those ones, at least, they sort of all follow the rules of table 24 and looking at the standard electrode potential values, with more negative values being less likely to happen and less negative being more likely to happen. So this last one is going to be our exception to the rule. Like we've seen in pretty much every topic, for every good rule that we have, there is an exception, at least one. And so this one is that when we have chloride solutions, okay, let's fix this formatting. When we have chloride solutions, we're going to have to consider something strange happening, an exception to our rule, and it's concentration dependent. So what exactly is the issue? So if we look at what's going on here, this is our water half equation. And we know that when we are considering it at the Po electrode, the positive electrode, we're looking at the reverse reaction. So water being oxidized has an electrode potential of minus 1.23 volts. And right here is the chlorine process, the chloride process. So if chloride ions are going to get oxidized into chlorine gas, that would have a value of negative 1.36 volts. So let me write that versus. So according to our rules, we would predict that if we have a solution of chloride ions, which is fairly common, chloride ions are quite common even in our tap water or our most common aqueous ionic compound solution, sodium chloride. So there's a lot of examples where we could see chloride ions in solution. Based on our numbers, we would predict that the water is the less negative electrode potential, and therefore the oxygen should be the main product at the positive electrode. So that's exactly what you should be predicting based on our rules, based on the table, and based on interpreting how negative these electrode potential values are. So if you're following the rules, you should predict that oxygen is the product when we have a solution of chloride ions. However, what turns out to be the case is that this is concentration dependent. At low concentrations, that's exactly what happens. So if we have a low concentration of chloride ions, then write that here. So at low concentrations, way too large. Let's shrink that down. Okay, at low concentrations of Cl ions, oxygen is the major product of oxidation at the positive electrode. The exception that you have to remember, that IB loves to ask about, and that you don't really have to explain, I'll give a brief, simple explanation that doesn't really get into, it's actually quite a complex thing about why this exception occurs. But you just have to remember that it does occur. And so the exception is that at high concentrations, and I know it's like, well, what exactly does that mean? Usually the question will indicate somehow that you're at a high concentration. So it might say that you have like a 1 molar solution. That's a relatively high concentration of salt. It might say that you have a saturated solution. It might give you two examples, and one is dilute and one is concentrated. So it might say that it's concentrated. that it's more concentrated. So these are all just different, vocabulary, different terms they might include that would indicate to you that should be a trigger term for you that we're dealing with a more concentrated or a high concentrated solution of chloride ions. So at high concentrations of Cl ions, then oxygen is actually not the major product, and chlorine gas becomes the major product. So this is nothing that you should expect to happen based on our rules. It is an exception to the rule, as we've learned many exceptions in the past, and unfortunately, exceptions need to be memorized because they are exceptions, and they like to ask about this one. So you are going to be expected, whether it be paper 1 or paper 2, to know that if you have a solution with Cl- ions at the positive electrode for electrolysis, chlorine will be the major product, not oxygen. And that changes like the electron ratios, and it has different impacts. So the first thing is that you can observe that this happens. If we were in class, I would show you a demo where as you use a low concentration chloride solution, you end up making oxygen, and you can test that this half equation is occurring because you can test the pH, and the pH drops significantly when this first equation happens because you're making hydrogen ions. If you use a solution that has a higher concentration, you notice that instead of the pH dropping, if you use pH paper, so this blue paper turns red in the presence of acid. So in the first example, the paper turns red. In the second example, the paper gets bleached. It turns white. And the reason why it turns white is that when chlorine goes into water, it actually produces hypochlorous acid and the hypochlorite ion, which is the same ion that is in bleach. And so it's evidence that actually you are producing chlorine. The chlorine is making this hypochlorous acid, and the hypochlorous acid is what's bleaching your pH paper. So you can experimentally test that this is what's happening. So that's what you need to know for the IB. You need to know that low concentrations of chloride ions, you follow the rules, and oxygen is the product at the PO electrode. But at higher concentrations, triggered by a number of these other terms, then the major product is chlorine gas. And so these are these kind of trigger words that would tell you that you're at a higher concentration. The concept is based on something called overvoltage, which is essentially as the process happens and gas starts to be formed at the electrode, it becomes more difficult for the oxygen gas to form. And it actually then requires a higher voltage in order to form that oxygen gas. And so at the higher concentrations, it becomes more and more difficult to form the oxygen gas in these situations. And so then you end up having chloride ions. There's a lot more prevalent chloride ions. And so for chloride, it ends up being easier for the chloride to form into chlorine. That just sort of very briefly scratches the surface of what's going on here. People have done IAs on this topic to see how the concentration exactly affects the ratio of oxygen to chlorine that's being produced. So it's one that's a good choice for people if they're interested in it. But for now, the last bit to remember for the redox topic that could come up is when you deal with chloride solutions, be aware of any information they've given you about concentration, because that will affect whether or not you make oxygen at the PO electrode or whether you make chlorine gas at the PO electrode.